All right, so we're looking at addition and subtraction of rationals. And with addition and subtraction, we need a common denominator to add the two fractions together. So when we look at number 16 here, our two denominators are 7b squared and 3ab. So we want to see what they have in common. They both have a b in the denominator. So that's going to be our starting point for our LCD, is they have a b in common. So b squared is the highest exponent. So I'm going to need to multiply the second fraction by another b so that I can make it b squared. 7 times 3, they don't have any common common factors, so the common denominator or multiple of 7 and 3 is just 21. A b squared, and then they're going to need an a because there's an a in the second fraction. So in order to make them the same, I have to have at least one of everything that's represented. So 21 b squared a is what I'm looking for. Now the first fraction here has 7b squared, so it's missing a 3a. So I'm going to multiply by 3a in the numerator and in the denominator. The second fraction is missing a 7b, and so I'm going to multiply by 7b in the numerator and the denominator. So in the top, when I multiply, I get 18ac over 21ab squared plus 14bd over 21ab squared. So that's my common denominator. So I'm going to put this together, add it under one fraction. Oops. And these two don't have any common variables, so I can't add them together. All right, so now we have three denominators to look at. We want to find our LCD. Notice here this means x plus 3 and x plus 3, right? There's two of them. So our LCD is going to have x plus 3 squared in it. So it has to have the most of any common factor. And then the last thing that's not in there is the 2x. So I'm going to take my first fraction, 3 over 2x, and I'm going to multiply by what's missing, x plus 3, x plus 3. And I'll just write it squared on the bottom. And then my second fraction, x plus 2, is missing the 2x, and over x plus 3 squared times the 2x, that's what was missing. And then my last fraction, negative 2 over x plus 3, is missing the 2x and an x plus 3. So now I need to distribute before I can simplify. I have to make it into one fraction before I can do any simplifying. So x plus 3 times x plus 3 is x squared plus 6x plus 9, which is then 3x squared plus 18x plus 27 over 2x times x plus 3 squared minus 2x squared plus 4x over 2x times x plus 3 squared, and then plus negative 4x squared plus negative, no, it's going to be minus, because negative 4x times 3 is minus 12x over 2x times x plus 3 squared. Now I need to be very careful with this negative. It's minus 2x, but it's also minus 4x. So when I combine my like terms, I get 3x squared minus 2x squared, which is x squared, minus 4x squared is negative 3x squared. Then I have 18x minus 4x, which is 14x, positive 14x, minus 12x is minus 2x, plus 2x, plus 2x, and then I have plus 27. and put that over my common denominator, 2x times x plus 3 squared. Question is, can I factor this? If we look at 27, that's 9 and 3. And no, it's not factorable, so that's my final answer. Okay, let's look at number 18. We have m over m squared minus 4 plus 2 over 3 plus 6m. So in order to find my LCD, I want to factor m plus 2, m minus 2, and 3 times m plus 2. So my LCD is what they have in common, m plus 2, and then everything else that's missing, the m minus 2, everything they don't have in common, and the 3. So in my first fraction, it's only missing the 3, so I'm going to multiply times 3. And my second fraction is missing the m minus 2, so I'm going to multiply by m minus 2. And so I get 3m over 3 times m plus 2m minus 2 plus 2m minus 4 over 3m plus 2m minus 2. And now I'm going to add these together before I try to do any simplifying. So I get 5m minus 4 over 3 times m plus 2m minus 2. And that is my final answer there. And I can't really simplify that. I could multiply out the denominator if I wanted to, but you don't have to. Number 19. 19 is a complex fraction. It's going to require us to simplify the top first, simplify the bottom second, and then divide last. So when I look at 3 plus 5 over a plus 2, we can see that a plus 2 has to be our denominator because there's a 1 under that 3. So I'm going to multiply 3 times a plus 2 over a plus 2 plus 5 over a plus 2. So distribute 3a plus 6 plus the 5. And that's 3a plus 11 over a plus 2. Okay, that can't be factored, so that can't be simplified. This is the numerator. Now let's look at the denominator. 3 over 1 minus 10 over a plus 7. So I'm going to multiply this by a plus 7 over a plus 7. We get 3a plus 21 over a plus 7 minus 10 over a plus 7, which is 3a plus 11 over a plus 7. This is my denominator. So I end up with, let's see, 3a plus 11 over a plus 2 divided by 3a plus 11 over a plus 7. So when I divide, I multiply by the reciprocal. 3a plus 11 over a plus 2 times a plus 7 over 3a plus 11. The 3a plus 11 divides out, and we have a plus 7 over a plus 2. And that's your answer. Okay, number 20. We already have a common denominator, and this was commonly missed on the quiz. We missed this because we tried to factor everything, and if I already have the common denominator, my first step is to just subtract my numerators. So 3x minus 7x minus 12, distributing the negative to both the 7x and the 12, over x squared plus 5x plus 6. That's negative 4x minus 12. And let's factor the denominator. A lot of people missed factoring the denominator, x plus 3x plus 2, and then you missed the simplifying part. Factor out a negative 4 in the top, and you get x plus 3. And that simplifies with the x plus 3 in the denominator. So don't forget to factor and simplify So we get negative 4 over x plus 2. And remember, this x plus 2 is together, cannot be separated, so you can't do any more simplifying at this point. Okay, so what makes this one different from the rest? And that's the equal sign. And we use the method called fraction buster. It's different from adding and subtracting in that we want to eliminate the fraction completely so we can solve an equation without one. So this is a different process than adding or subtracting, and it's really important that you pay attention to how to do these ones and how they're different from the adding and subtracting problems. We are going to look at the LCD, and if I factor x squared minus 16, I get x plus 4, x minus 4. So my LCD is going to be x plus 4, x minus 4. Now my goal on this problem is not to get a common denominator and add everything together, but to use my common denominator to eliminate the fraction. So what I'm going to do is multiply by x minus 4, x plus 4, in the numerator of each fraction. And I don't have a lot of space here. In this one, x plus 4 times x minus 4. So let me rewrite this out. I get 12 over x plus 4, x minus 4. The black is what I have originally, and the red is what we're going to multiply by to eliminate our fractions. Minus 24 over x plus 4. We're going to times by x plus 4, x minus 4. And this is not a plus, this is a minus down here. And that equals 3 times x plus 4, x minus 4. And so when I'm solving the equations, my goal again is to eliminate the fraction. So I am going to simplify it out. Here, the x plus 4 and the x minus 4 cancels, and we're left with 12. The x minus 4 cancels, and we're left with negative 24 times x plus 4. And on this side, we have 3 times x squared minus 16 if I multiply out the x plus 4, x minus 4. So 24 times x, that's negative 24x, and 24 times 4 is negative 96, and that equals 3x squared minus 48. So you see how multiplying the numerators by the common denominator gave me a fraction or an equation with no fractions in it, and it's much easier to solve at this point. So we're going to combine our like terms and put it all on one side and solve. So when I do this, I get negative 96 plus 12 on this side. These like terms are going to be negative 84. So negative 24x minus 84 equals 3x squared minus 48. We're going to add 24x and add 84. And I'm left with here 0 equals 3x squared plus 24x, and 84 minus 48 is 36, so plus 36. Running out of space. Factor out a 3 to make my factoring easier. X squared plus 8x plus 12. And then we have 3 times x plus 6, x plus 2. And so x is equal to negative 6 and negative 2. And neither of those, when I look at these numbers, negative 6, and I plug them into my equation, will make the denominator equal to 0. So both answers are correct, or both answers work. All right, here's another equation to solve. Again, we're going to use fraction buster, and this method is different from what we do to just add them together. It's because it's an equal sign, we can just get rid of the fractions. 12 is 3 times 4, so let's look at that. So my LCD is going to be 12D. because I can multiply the 4 to get 12. So I'm going to multiply all of my fractions here by 12d. Okay, and I get 2 over d times 12d plus 1/4, let's make that blue, times 12d equals 11 over 12 times 12d. Remember, it's really over 1 because my goal, again, is to get rid of the fraction. So the d cancels here, and 2 times 12 is 24. And I can say, oh, 12 divided by 4 is 3. So this is 3d. Put that in red. And then the 12s cancel there, and we get equals 11d. And then we can subtract 3d. 24 equals 8d, and d equals 3. If I plug that in to my equation up here, it doesn't make the denominator 0, so d is an answer. And last problem. So here my LCD, 2 is a factor of 6. So my LCD is going to be 6 times x minus 6. And remember, the x minus 6 is a separate factor, so you can't say that those 6's are in common. I'm going to multiply all of my fractions by that. So times 6 times x minus 6 plus 2 over x minus 6 times 6 times x minus 6 and plus, or equals 1 over 2 times 6 times x minus 6. So in my first fraction, my 30, if I multiply it together, 30 divided by 6 is 5. If I cancel it, the 6 and the 6 cancel, and we still get 5 times x minus 6. And in my second fraction, the x minus 6 divides out, and I get 2 times 6, which is 12. And in my last one over here, I get 6 divided by 2, which is 3, so 3 times x minus 6. So let's see, 5x minus 30 plus 12 equals 3x minus 18. That's 5x minus 18 equals 3x minus 18. I'm going to add 18, and I get 5x equals 3x, and I subtract my 3x. What do I get? I get 2x, but what is on this side? It's equal to 0, and that's not anything wrong. It's not no solution. 2x equals 0. Divide by 2. I'm allowed to divide 0 by a number, so x is equal to 0. And does that make the denominator 0? No, it does not. So that's my final answer. So it's not extraneous. Make sure you're checking for extraneous solutions on the test. Plug them back in. If I plug in a 0 here, we can see that we end up with 5/6 plus negative 2/6, which is 3/6, which equals 1/2. So it does work.